Okay, Algebra 2, this is Lesson 6, and we're going to graph the reciprocal parent function, which the reciprocal parent function is the function f of x equals 1 over x. All right, so we've been studying fractions basically, and this is our fraction function. All right, what this function looks like is it looks like this. You might want to pick a couple points. So if you plug in 1, you get 1, so it goes through 1, 1. And if you plug in -1, you get -1. So that's a good point to use as a reference. But it looks like this. It does have two asymptotes, the x and y axis. So the type of graph is it's a hyperbola. All right, the domain is all real numbers or -infinity to infinity if you prefer. Range, same thing, all real numbers or -infinity to infinity. The vertical asymptote is the y-axis, which is the line x equals 0, right? Y can be anything. And the horizontal asymptote is the line y equals 0, which is the x-axis. Y equals 0, and x can be anything. All right. Okay, next is what we're going to call standard form. So, like we've been doing all year long with these functions, we start with the parent function, and then we do some things like multiply it by some number a, and then we subtract or add a number to x, and we can also subtract or add a number to the actual entire function. Right, and those things still stay the same. If we subtract a number from x, it moves it to the right. This is going to be our stretch, our vertical stretch, and this is going to be our vertical shift, up or down, depending on whether k is positive or negative. So that's what all this stuff is, right? And I'll just go ahead and fill it out for you to save you time, and then we'll talk about it a little bit. Okay, so if we look at a function that you're familiar with, if you remember, like here's our quadratic, right? Our parent function was x squared, and we subtracted h from it, and we added k, and we multiplied by a. So we're doing the same exact thing here to our parent function, The only difference is it's just a different function. But everything else stays the same. When we subtract a number from x, it moves it to the right or left, depending on the sign of this. When we add a number out here, it moves it up or down. And the a affects the vertical shrink or stretch or shrink, and then it also, if it's negative, it opens down. So all that stuff is still the same with this function, and that's what all this tells you. Okay, so horizontal shift, positive left, negative right, vertical shift, positive up, negative down. If a is negative, it's reflected across the x-axis just like before, and if a is less than, the absolute value of a is greater than 1, it's a stretch. So if you have a 3 up here, it's going to be a stretch. But if the number is between 0 and 1, like 0.5 or -0.5, then it's a shrink. All right, the vertical asymptote is x equals h. The horizontal asymptote is y equals k. All right, so let's do some examples here. Okay, so we're going to take the parent function in this first example, and we're going to reflect it across the x-axis. All right, so what that does is it takes our function, f of x equals 1 over x, and we reflect across the x-axis, we change the sign on a or change the sign out front. All right. Next, it's translated 4 units to the right. 4 units to the right, we subtract 4 from x. Subtract and it goes right, add it goes left. 3 units down, we subtract 3 from the whole thing. All right, so here's our function. Now, to identify the asymptotes, once again, x equals h. If you compare to standard form, then since we shifted this thing 4 units right, then we have x equals 4 for our vertical asymptote, and our horizontal asymptote is going to be y equals, and this thing's been shifted 3 units down, so y equals -3. And once again, y equals k is the vertical asymptote. Now we can always graph these on the calculator, so let's just do that real quick. So I'm going to go to y equals, and then alpha y equals, and do the fraction. And on the top, I'm going to put a -1, and in the bottom, I'm going to do my x minus 4, and then I have the -3. So if you see it, it's exactly what we're describing, right? This thing has been shifted, 4 units to the right, 3 units down, and instead of opening like this, it's been reflected over the x-axis. All right. Okay, the next one, let's try 3. So we want a reciprocal function that has a vertical asymptote located at -2, x equals -2, and a horizontal asymptote at y equals 5. So I like to sketch a quick graph of this. X equals -2 is right here. This is my vertical asymptote. and y equals 5. 1, 2, 3, 4, 5 is here. So you can tell the regular parent function, goes like that, and it's kind of centered at the origin. But this one now has been shifted, so it looks like this. So the question is, how has it been shifted? Well, it's been shifted back 1, 2 units, and then up 5. So I'm going to take my parent function, 1 over x, and I'm going to do those shifts. So back 2 would be adding 2, and then up 5 would be adding 5, like that. And that would be an example of a function that would do that. Now, there's multiple answers. I mean, you could have a negative here because it didn't say whether it was reflected. You could change this number to a 3 or a 4 or any other number because it didn't say whether it was vertically stretched. It just told us where the asymptotes were. So we need to go 2 to the left and up 5, which we did. Okay, let's try a couple other ones here. Number 5. It wants us to graph this, then identify the domain and range and the asymptotes. So this graph, if you look at it, the parent function is 1 over x, but this has a 3 added to it, so it's going to be shifted 3 units to the left. 1, 2, 3. So my asymptotes are going to still be vertical and horizontal. It's just the function now has been shifted back 3 units. So that one's pretty easy. The domain is going to be all real numbers, but x cannot be equal to -3. The vertical asymptote now is x equals this line here, which is -3. The range is all real numbers, except for y cannot be 0, right here. And the horizontal asymptote then is y equals 0. That doesn't change. Okay, let's get a little bit more challenging. The next one, number 7, this one's been shifted 2 units to the right and 2 units down. So 1, 2, 1, 2. Right? If we subtract from x, it moves it to the right, and if we subtract outside, it moves it down. So we know that the regular function looks like this with the asymptotes of the x and y axis. Now the asymptotes have been shifted 2 units to the right and 2 units down. So it's going to look something like this. But this 3 up here is a vertical stretch. So where before it went through this point, 1 up and 1 over from this intersection of the asymptotes, well, now, because it's vertically stretched, it's going to be up 3. It's been vertically stretched by a factor of 3. And you could always plug in a point, If this is the point 2, you can plug in 3 and see what happens. 3 over 3 minus 2 minus 2. This gives you 3 minus 2, which is 1. So it goes through the point 3, comma 1. I plugged in 3, and I got out 1, so that means it goes through this point right here. So the graph is vertically stretched, basically. All right, so instead of going through this point, it goes through this point. All right, so you can always plot points if you're not sure exactly how the stretch is, but obviously you definitely need to have the intersection. I'll call this the center, but it's the intersection of the asymptotes. You need to have that right, and you need to have the shape of the graph right. Outside of that, I wouldn't be too picky. Not that you guys are getting quizzed in tests really anyway, but just try to graph these right. You can always use your calculator. So, take out your calculator, and I shouldn't say always. I guess you can't use it on the no calculator, the SAT, or many college courses. But in our class, you can always use it. So we're going to graph this. Whoops, -2. All right, and we should see basically what I graphed here. All right. And you guys know you can always go to the table, second table, and you can look at points. I told you the point 3 was 1, so let's go to 3 and make sure it's 3, 1. It is. This point down here should be 1, negative 1, 2, 3, 4, 5. So let's go to 1 and make sure it's -5. It is. So you can always graph. The asymptote is the error, right? At 2, we know there's a vertical asymptote at x equals 2, so we expect to see an error there. So we can always double check with our calculator. Oh, and the domain is going to be all numbers except 4. So I'm going to say all real numbers, but x cannot be 2. The vertical asymptote then would be x equals 2. And then the range is all real numbers, but y cannot be equal to -2. And the horizontal asymptote then is y equals -2. Okay, one more problem before you guys start the homework. This is a tough one because now we have a reflection in there, that negative sign. All right, so normally the parent function looks like this, but now because of the reflection, it's going to look like this. So just keep that in mind when we go to sketch the final version of this. But it's been shifted 5 units to the right. So 1, 2, 3, 4, 5. It's been shifted 3 units up. So there's the intersection of my horizontal and vertical asymptotes. All right, and now normally the function would look like this, like I said, but because of the reflection, now it looks like this. All right, and that's it. There's no vertical stretch or anything like that. So the domain looks like it's all real numbers. X cannot be 5. And the vertical asymptote then would be x equals 5, right here. And then the range, all real numbers, y cannot be equal to 3. And the horizontal asymptote is y equals 3. X can be anything. All right, and if we double check that in our calculator, go to y equals and plug it in. Alpha y equals fraction, and you have -1 in the numerator, and in the bottom you have x minus 5, and then that's plus 3. Take a look at the graph, and it should look like what we have here, and it does. And we can verify the table if you want to, check some other points, but that's pretty much it. There's really nothing new in this section. We've been doing this same stuff all year long with other functions. So we did the exact same thing with parabolas, with linear functions, with the the square root function. So hopefully this is familiar. Hopefully this is easy. If you have any questions, let me know. Hope this helps. And I hope you have a fantastic day.